All right, guys. Level 3 help desk. Yes. I know I've actually been a bit quiet with the whole level 2 maths thing, but man, that was just a bit crazy. I did not see that coming at all. Like, you know, I mean, considering that the level 1s had a really tough tables, equations, and graph last year, I thought actually they might just keep it kind of simple, but man, the level 2 paper was just sad. That's all I can say. I don't know why they had to make it so complicated, but more about that later, guys. But I thought I'll talk a little bit more about the level 2 maths one maybe after the calculus exam is finished. SK Gaming. I don't mind doing that if that's what everybody wants to do. How about, let's say, look, I mean, I did the 2018 paper last. I think you guys got all the 2018 papers. So if there's any particular questions that you want me to go through from the past NCEA papers, then just tell me which one you guys want me to go through. We'll go through the same theme. So we'll start with the complex numbers one first, then we'll go to differentiation, and then go to integration, and we'll do one at a time. Yeah, tough luck, Micah. That was really crap for you guys. I actually would like to see what they do with the marking schedule, because I'm sure they'll come up with something interesting. All right, so complex numbers. What shall we do first in complex numbers? Tell me a particular complex numbers paper, and I'll go pick up the question. Modulus question, please. Yeah, complex numbers first, guys. So tell me, should we do a roots question from 2017 complex numbers first? Looking for it, hold on. Oh, nice. Okay, let's do this one here first. We'll take a screenshot of it and chuck it up there. No, wrong one. Control C, where is my images? Code, it might be possible, but I'd actually say check out the limits tutorial that I put for differentiation in level 3 tutorials. You can actually get easy 5 points from that as well. All right, guys, so the first question we're looking at is this one here. Five, 7, 7. So this is from 2017 question 2D, which is actually worth a merit. Okay, I'll put that up next. SKK Gaming. I need a request box, don't I? So what we've got. what did he say? 2016 3E. And Dampier, you want a 2016 3E as well. Yeah, I mean, look, let's get started with this question, all right? Like, so I always say this to you guys first. You know, when I actually do this is a merit question. I really want to be spending on merit and excellence questions in these next two kind of sessions. So let's get started. The way I do this, and you might do this completely differently, that's absolutely fine. The way I do it is like I basically just draw the complex number first. So when I draw the complex number, I can see that it is, the real part is the same as the imaginary part. So you've got m over root 2 and m over root 2 there. Because of that, the argument is going to be 45 degrees. The other thing is I need to find the modulus, which is this part there. So the modulus is equal to square root of m over square root of 2 squared plus m over square root of 2 squared. I should really put this as modulus. So then modulus is equal to square root of m squared over 2 plus m squared over 2, which is going to give me 2m squared over 2. And if I square root that, I'm going to get just m. So in saying that, I always tell you guys, so then you can rewrite this as z to the power of 4 equals m cis 45 degrees. Matt Wiley, I doubt they're gonna do it that much, because I mean, like, we're talking about a hell of a lot of kids that are depending on university entrance on these calculus exams at level 3. But mind you, in saying that, I don't know what what NCEA gets up to. Emily, no, it doesn't matter whether it's in degrees or radians. You can do whatever it is that's easy for you. Okay, so the first root is going to be, I need to actually go z1 is equal to m cis 45 to the power of a quarter. So z1 is equal to m to the power of quarter cis 45 divided by 4. So it's going to be m quarter cis, now 45 divided by 4, that is 11.25 degrees. Just going and having a look quickly. Yeah, we're good to go with that. And from here, if you guys have been following my videos, you know that when you have z4, you're going to have 4 roots, which means you find the first root, then add 90 degrees all the way through, which means z2, z3, z4, they're all going to have m to the power of quarter, cis, and you literally just add 90 degrees to 11.25 and just keep adding 90 degrees. So that's going to be 101.25, 191.25, and 281.25. Dana, should it be like m squared minus half? No, because we got 2m squared over 2. Then we're going to have square root of m squared, because 2 over 2 is 1. And we're going to end up with modulus is equal to m. Why did you power it by a quarter? Indeed, that's one of the De Moivre's theorem. So if you have De Moivre's theorem, I think they have something like, damn it. let me see if I can pull up from the complex calculus formula sheet. It is given to you guys in the formula sheet. Level 3 formula sheet, De Moivre's theorem, De Moivre's theorem. There we go. So because I want to find one root, right? That's why I got to go to the power of quarter. No worries, TS. You're welcome, man. Seb, the point of doing modulus and argument is the only time you can actually use De Moivre's theorem. The only time you have to use De Moivre's theorem is that you've got to have r is theta. So that means I need to convert, if you look at original z, which I've highlighted in green here, that's actually in rectangular form. So I need to convert this to polar form because I need to have polar form to actually use De Moivre's theorem. If the modulus was below the RE real axis, x, will the argument be negative? Locos, yes, you could actually have the argument negative, or you could have it going all the way around as well. So say, for example, you have a situation like this. So something like 3 minus 3i, right? Then what's going to happen is that's 3 and that's negative 3. So your argument is either minus 45 degrees or all the way around, which is 315 degrees. Learn, coach. So guys, are we okay with this question? Can we go to that differentiation question next? Yeah, I think I spent, what was it, a good hour going through this complex roots in a couple of tutorials ago. So just, if you guys are still stuck on this, please make sure you have a look at this, because there are, I think the most complicated part for complex roots is going from the green to the blue part. I think if you get that right, then you pretty much can easily guarantee to get an easy merit. Oceanic chat, just find me a question on NZQA past papers and I'll get it done, man. Cool. So we are going to differentiation question 2016 3E. All right, let me pull it up. What did you pick for me, Dampier? Oh my lord. Talk about ugly question right there, Dampier. Okay, let me find some space. Emily, got your question, 2017 2E. I need a different paper. Hang on, I can't keep track of it. So what do we have? Complex differentiation integration. 2016 3, 2017 2e, and we have 2016 3e as well. Okay, so let's do this question first, guys, and then we'll go into, yeah, sorry, I've only got a few questions up there, but this is the next question we're looking at. This is a differentiation question. All right, what have we got? Try score 15 meters from the left hand. Conversion kick has taken us on the line perpendicular to the goal line from the point where the, yeah, okay, whatever. Ball needs to pass, which is 5.4. Maximize the angle theta. Oh yeah, okay. That is stink that they make you guys do this, but anyway, sorry, I'm just gonna come back to this. Which is, you can find out how it is. Cool. So what the question's actually asking here first, all right? They want to know how far, find the distance so that the angle is actually, theta is the biggest, all right? So they want to know when is this angle going to be the biggest depending on the distance, because think about it. So if the distance was like really short, right? And if the goalpost is like that, then the angle theta, it might be, I think it's a little bit bigger. And I think that's 15 meters. I know this is a really ugly kind of thing, but let me try and do this again just to give you a better idea. If he decides to take a kick from here, then that becomes the distance. And then you can kind of see that this red theta is probably slightly bigger maybe than the small theta. All right, so that's what's happening at the moment, right? And then that's alpha. So what we're going to do is we're going to separate this into two triangles. So I'm going to get rid of all these things. So the first triangle I'm going to be looking at is this yellow one here. Then I'm going to look at the second triangle, which is the blue one. So with the yellow one, what I've got is I can write this tan of alpha, so that's opposite over adjacent, which is going to be 15 over d. Then I can also see tan of alpha plus theta equals 20.4 over d. Okay, so far so good. Now the next thing is that we've got to actually differentiate theta, all right? Because we want to actually try and figure out, or we write d in terms of theta as well. That's another way of like trying to think about it. But what are these guys done here? I wonder if we do it that way. Can I just try it? I just want to try it. Give me 1 second, guys. want to see if this actually works out or not. No, I can't write d. I'm trying to differentiate tan theta. It's not going to work out. Because what I'm trying to figure out is basically differentiation of tan theta over dd. So that's not going to work out. Let me show you guys what these guys have tried to do, all right? So what these guys try to do was they actually try to prove, they actually did it like this. Tan theta could be written as tan alpha plus theta minus alpha. It's kind of like how do I put it? They decided to rewrite tan theta as with alphas, but then if you think about it, if you expand this out, right, we're gonna get not expanded. You're gonna leave it like this with another bracket in there. I'm losing my brackets today. 1, 2, 3. Yep. I hope that makes sense there, guys, because I know it looks weird, but like the whole point is like it's like this. It's like if you have like 10, you want to write 10 as basically this is what they're trying to do. 10 plus 3 minus 3, something like this. I hope that made sense what they were trying to do there. So because of that, the next thing we need to do is we need to actually pick up a tan rule from the formula sheet. Which is this one here, compound rules. I'm just going to put that up there. Give me a second, guys. Okay, and the other thing I'm going to do is just be patient with me because I know this is a bit annoying, this question. I'm going to bring that down here. So we're going to rewrite this as now, because of that, we're going to rewrite this as tan theta equals, and we can kind of say that A part equals this, and B part equals this. So we're going to rewrite this as tan. Instead of A, we're going to put down alpha plus theta plus tan of, actually it's not going to be plus, it's going to be minus just alpha by itself, and then that's divided by 1 plus tan alpha plus theta tan alpha. I hope that actually made sense there, guys. Ugly question, as I said. Okay, because we have this, now what we can do is we can rewrite this because we already got what tan alpha plus theta is. That's 20.4 over d. And we also have what tan alpha is because that's 15 over d. So then we can rewrite this as 20.4 over d minus 15 over d divided by 1 plus 20.4 d multiplied by 15 over d. Okay, so what we're then going to get is what do we got? 5.4d 5.4 over d, and the whole thing is divided by 1 plus 20.4 times 15 is 306. So we're going to get 306 d squared. Now this is still just tan theta. All of this is just tan theta. So then kind of write this as tan theta is 5.4 over d, and the whole thing is divided by d squared plus 306 over d squared. As you can see, it just keeps going, this question. So we've got 5.4 over d, and the whole thing is divided by d squared plus 306 over d squared. And I'm going to kind of do this the old-fashioned way. So if it's divided, then it'll be cross-multiplied. D squared over d squared plus 306. So that d and d cancels out, and we're left over with 5.4d over d squared plus 306. Did I miss Jacob? I'm sorry about the identity, man. Just the trig identity is yeah, I think you guys would have had to do it if just got to kind of go through it real quickly. Now, because Dampier, we can't actually differentiate that with tan because tan theta is equal to that. Because remember, you're how do I put it? It's like you're trying to figure out what is tan theta is a function, right? Just like y value kind of thing. So you can't just differentiate it. But what you can do is you can differentiate the one with d's in it, and then we can kind of work it out. So in other words, what you can do is you can kind of say that the maximum happens when you differentiate tan theta with respect to d. So I'm talking about this d here. So what you got to do is you got to differentiate this using quotient rule. So when we differentiate this with quotient rule, what we're going to get is 5.4 multiplied by d squared plus 306 minus 5.4d multiplied by 2d, and the whole thing over d squared plus 306 squared. Okay, so now this is all equal to 0. So we're going to put this equal to 0, and we've got 5.4 d squared plus 306 minus 10.8 d squared over d squared plus 306 squared. Now, because the denominator multiplying by the 0 on the other side is going to equal to 0, and we're left with just 0 is equal to, just going to kind of work this through quickly. We've got 5.4 d squared minus 5.4 times 306, whatever that is, minus 10.8 d squared. So 0 is equal to negative 5.4 d squared minus 1652.4. And we're nearly there, folks. We're nearly there. So rearranging this, I'm going to get, something's not right here. Where am I getting minus? That should be plus. So 5.4 d squared is equal to 1652.4, and d squared is equal to 1652.4 divided by 5.4. So d squared is equal to 306. So finally we get there. D is equal to 17.9 something meters. 17.5. Super annoying question. Now, Jacob, we're not actually differentiating tan theta at all. We're actually differentiating what it's equal to, what that function is equal to. So if you notice, so tan theta equals to this thing here in the green box, and we're differentiating that. It's kind of like saying like this, guys, because remember when you go like, what's the maximum value for y, right? Think about it like this. So when you had a function like this, y is equal to x squared plus 3x plus 4 or whatever, right? You were asked, well, what is the maximum or minimum value for y, right? Then what you would actually do is you would actually differentiate, put it equal to 0. No, we're not doing implicit in this case. We're simply just going differentiation of that function itself. 2017 2e. Yes, Micah, Sunday nights are a pain, man. 2015 3e. Mark, and I hope it's not another one of these freaking triangle questions. Jacob, no, I don't. I'm simply just a maths teacher, man. I don't even teach calculus this year. In fact, I don't even teach level 1 maths this year, but yet I am here. All right, so next up I had integration paper 2017. Damn it, got the wrong one. Just theta respect to d. What do we got? 2017 question 3e. Where is it? Where is it? Wow. Fun times. Okay, let's do question 3e coming up. It's actually not too bad, this question, guys. Actually, this is a lot. I'll put it on my list. Shannon, 2015 1e. It's all right, Chloe. It's not a problem. All right, so we are doing, this is question 2017, question 3e. So guys, this question here, I think when I look at some of the more complicated integration questions, this is a pretty straightforward one. So the kind of key things to look at is this here. See how this is cos 0.5t and then this is sine 0.5t. I think that's your first kind of clue. All right, and also this is actually an exponential function, because remember, when you differentiate an exponential function, so if we have e of x squared and if we differentiate it, we are going to get 2x e to the power of x squared. All right, so that's literally what's happening here. So the first thing I'm going to do is I'm going to integrate k cos 0.5t multiplied by e sine 0.5t. So I'm going to put this as dt. So then I'm going to get y is equal to k cos 0.5t. When I integrate exponential functions, I leave everything as it is, but I have to divide by the differentiation of sine of 0.5t. All right, now when I differentiate sine of 0.5t, I'm going to get 0.5 cos 0.5t. Yeah, I hope you guys are okay with that, because that's the trickiest part, because after that you're pretty much good to go. Hey guys, just another thing, just kind of, can you guys keep the chat to just some questions on maths, because like really I've pretty exhausted at the moment. I don't mind going to sleep, but if people want to chat about other things, then I'm quite happy to leave this, just leaving. But so would you mind leaving this just for questions, please? I'd really appreciate it. Thanks, Rory. Yeah, I do need a plus C in there. Kind of got sidetracked by what was happening in the chat. Nah. Emily, because it's an exponential function, what happens is this part and this part kind of cancels out each other. So you're left over with y is equal to k divided by 0.5 e sine 0.5t plus c. Okay, so that's what happens to that cos 0.5t. Kevin, I will probably have a debrief of level 2 papers after Tuesday when these guys have finished calculus exam. So right now I'm just trying to get some of these guys through, man. So cool. So what you have is basically this equation. Now I'm going to get rid of the 0.5 and I'm going to rewrite this as 2, because k divided by half is just 2. So 2k e sine 0.5t plus c. And I guess this is where things become quite nice for you guys, because the first part of the question is, it says when t equals to 0, y is equal to 8. So I'm going to do that part here, because t is equal to 0, y is equal to 8. So 8 is equal to 2k e sine 0.5 multiplied by 0 plus c. Okay, and because of that, we know that, what do we get? We get Am I missing something here? We've got sine of 0. Sine of 0 is just 0. So e of 0. No, this becomes e of 0 plus c. Now e of 0 is just 1. So we're going to get our first equation, which is 8 is equal to 2k plus c. Sin x integrate. Callum, I'm not integrating sin x. I'm actually differentiating sin x because that's one of the rules for exponential integration. And Evan, it's not over 2, it's actually over half. It's the same as 2x. So if something is divided by a half, it's the same thing as saying multiplying it by 2. Okay, so that's my first equation. Now I got to get my second equation, which is t equals to 2 and y is 12. So I've got t is equal to 2 and y is equal to 12. So I'm going to repeat the process again. So I've got 8 is equal to 2k e sine of 0.5 multiplied by 2. Plus c. And I think because we're using sine of, what is going to happen is it's going to be like this. 8 is equal to 2k e sine of 1 plus c. But we actually need what sine of 1 is. Which is that. And then we've got also e to the power of that. So e to the power of that is equal to roughly 2.31. So I'm going to use 3.32. Oh, and I realized I made a mistake. Does anybody see my mistake there? Yeah, thank you. Appreciate it. That should be 12. So times 2. What was the calculator answer there? 2.32 plus c. So we've got 12 is equal to 4.64 k plus c. So I hope you guys can see what's happening here. We've actually got Kian, we're going to be going through this pretty much. I've got another few more questions that I'm going to be going through, man. So yeah. So what we've got here is two simultaneous equations. So that's going to be equation 1 and equation 2. So we've got 8 equals 2k plus c and 12 equals 4.64k plus c. Now, I'm not going to waste my time trying to do this the long way, guys. I'm going to go directly into my calculator and put it in simultaneous equations and solve it. So what I got? 2, I've got 1 and 8. Then I've got 4.64, 1 and 12. So my k is going to be 1.51. And my c value is going to be 4.96, 4.96. Okay. So yes, it's completely two different papers, man. Yes, Kalisha, you would be absolutely fine. You don't need to be wasting time with like little level 1 stuff. Nah, Matt, not for simultaneous equations. You can just do it straight up in your calculator. Imesh, I'm gonna go back to this Imesh. I'm not integrating sign there. I'm actually differentiating it, because remember, when you integrate exponential functions, you still follow the differentiation rules for it. Cool. So I've got my equation. Now the question is actually asking find y when t is equal to 5. So t is equal to 5, and we want to know what y is. So the equation is y is equal to 2 times k, which is 1.5151, e of sine 0.5 times 5, plus c, which is plus 4.9696. E to the power of, what is it, sine of 0.5 times 5. I hope that's enough brackets there. 1, 2. $10.49. So can they ever give an ellipse locus as well? Dave, I've not seen an ellipse pop up in the last few years, but I can't really comment on it, man, because it is part of the curriculum. So if they cover conics in your school, then you probably know it. If they haven't covered conics, then it gets a bit tricky. So guys, grades wise, just to let you know, just this part here, getting to this part gets you a merit. Or even up to here. Simplifying it here could get you a merit, and then this gets you an excellence there. Fair enough. All right, so any questions on this at the moment? Edrin, do me a favor and just screenshot me the question to my email address. I'll put it in the description section there. Nah, Leah, I, like, the thing is, the ellipse one is a bit of an odd one, because I mean, you just have to know how to do completing the square for that. But apart from that, yeah, I've not, I don't know, I don't think I've seen it very often. All right, let's see. Next question request was 2016 3E. I hope I picked up the right question. These questions are just annoying. They're just freaking long, man. That's all right. We'll get it done. Okay, we're doing complex numbers next. Question 3E from 2016. Let me just have a quick look at it, guys, and then we'll go through it in a minute or two, but you guys can have a crack at it, as always. Markin, which paper is that, Markin? Differentiation 2013 2E. I don't know which paper you want, Markin. Oh, the last question wasn't there, 2 0.5. Oh, differentiation. Oh, yeah, that's coming up next, mate. It's coming up next. I've just done 2 of these. I'm doing a complex number. Okay, all right. Let's go through with this question here, folks. So what we always got to start with these kinds of questions is, see, the way it kind of works is this. You're given some sort of facts here, right? So because you've got some sort of facts, you've got to try and kind of work that out first. Once you work that out, then you actually go and do the second part of the question. So what I'm going to do is I'm going to put down them as 2 letters. All right. So I'm going to go with the same thing as the answer schedule so you guys can follow it. U is equal to A plus BI. And then V is equal to C plus DI. Because they're 2 complex numbers, I'm just going to put them as 2 different things here. Okay. So the first thing I'm going to work out is the modulus of U plus V squared. And so if you guys think about it, right, like if I do U plus V, I'm going to get A plus BI plus C plus DI. So this gets written as A plus C plus BI plus DI. Simplifying this, or actually factorizing it, and get B plus DI. So this complex number U plus V, it's going to look like this, where let's say it looks something like this, right? Now the real part is going to be A plus C, and the imaginary part is going to be B plus D. So if you think about it, the modulus squared, so this is where the modulus is. So the modulus squared is equal to the real part squared plus imaginary part squared. So if I look at my real part is A plus C, and then my imaginary part is B plus D. So this could be written, because the modulus of that is equal to A plus C squared plus B plus D squared. All right, so that's what the U plus V looks like. Now we're going to do the same thing, but we're going to do it for U minus V now. So U minus V, I'm going to do the same thing again. So it's going to be A plus BI minus C plus DI. So expanding the bracket, I'm going to get A plus BI minus C minus DI, which is equal to A minus C plus BI minus DI. Keep going, A minus C plus B minus DI. So if I look at what my real part is going to be A minus C, and my imaginary part is going to be B minus D. So then I can write U minus V, modulus of that is A minus C squared plus B minus D squared. Are you guys with me so far? Has chat gone completely quiet, or is it just not refreshing? Okay, give me a second. Oh, sweet. Sorry. Awesome. Thanks, Leah. So, at this point here, now we've got to try and kind of say, because we got to go back to that first initial statement, because notice how it says this left-hand side equals to right-hand side. So we want to say, basically what we're saying is that this red box, that these two red boxes are equal to each other. Not yet, but Destiny, if you actually expand it, if you expand the two statements, you actually get a merit for it. So what I mean by expanding is expand the red box first. So I've got a plus c squared plus b plus d squared is equal to, I'm going to get a squared plus 2ac plus c squared plus b squared plus 2bd plus d squared. So this is my u plus v squared. As for the u minus v, I've got a minus c squared plus b minus d squared. So expanding it out, I'm going to get a squared minus 2ac plus c squared plus b squared minus 2bd plus d squared. This part here gets you a merit. Simplify it once more, Jake. So now we can say that both of these red boxes, remember, so this was in the first red box, this is in the second red box, and we're going to put them equal to each other. The reason it's equal to each other is going back to the question. If you notice, it says the modulus of that equals to the other modulus. So we're going to put a squared plus 2ac plus c squared plus b squared plus 2bd plus d squared is equal to a squared minus 2ac plus c squared plus b squared minus 2bd plus d squared. So this is what this part is equal to. So we can start getting rid of a few things. So a squared cancels, d squared cancels, b squared cancels, c squared and c squared cancels. So what we've got, 2ac plus 2bd equals negative 2ac minus 2bd. Rearranging this, we're going to get 4ac plus 4bd equals to 0. Factorize. AC plus BD is equal to 0. So we can say that AC plus BD is equal to 0. Now remember, guys, this is the fact from the first part of the question. So all we've done right now, we have done just this part here. So that's what we've actually done, just the first part. This is from 2016 3E. For the equation to hold. 2016 3E, yeah. Cool. So this is all we've done. Now, as you guys can see, you actually get merit way before this point, right? So, but we are going to use this. Now we're going to actually go and look at what the question's actually asking us. The question's asking us, prove that UV is purely imaginary. And we actually said that u is equal to a plus bi and v is equal to c plus di. So here's the thing. We figured out so far, this is what we know. We know that AC plus BD equals to 0. We also know conjugate of V is equal to C minus DI. So we're going to do U multiplied by V, conjugate of V is going to be A plus BI multiplied by C minus DI. So expand the brackets out, we're going to get AC minus ADI plus CBI minus BDI squared. So I squared is equal to, we're going to get rid of this ADI plus the CBI minus BD multiplied by -1. So then AC minus ADI plus CBI plus BD. And what we've got is AC plus BD minus ADI plus CBI. Now we proved in the previous part that AC plus BD equals to 0. So we can say that because AC plus BD equals to 0, therefore U conjugate V is equal to, so this entire part here is equal to 0. So we're going to get ADI plus CBI, so it is purely imaginary. That's how you get that question there, guys. So going back to that question, as I said, it is a lot of kind of work on it, but these types of questions is it's quite nice because they actually work out. You know, you've got what the answer is going to look like. So you just need to understand when they say something like purely imaginary, that means real part is equal to 0. And when they say it's purely real, that means the imaginary part is equal to 0. So those are some of the couple of hints that are really useful to keep going forward. Okay, if you guys got any questions, just pop it up there. Otherwise, we're doing, I hope this is not another triangle question, because otherwise I will cry. 2015 3E. Hang on, I thought I did question 2015 3E before. Whoever asked me to do question 2015 3E on differentiation, I've actually done it in the last help desk, so if you guys have a look at it. So somebody asked me for so just have a look at the previous help desk, guys, because I did 2015 3E. I'm sure. Let me just double check. Give me a second. Where was this? Yep, I have. There we go. Somebody asked me for it last time. So it's like the third question in the last tutorial that I did. Okay, so we've got 2013 2E coming up. Yes, Destiny, I'll be opening it up. So, but I won't be repeating any questions, guys. So you just have to keep. I've got a record of questions that I'm doing at the moment. But more importantly, if I see it, I recognize it pretty straightforward. So whether I've done it or not. Okay, so we're doing question 13 2E, 2013 2E. Oh man, another knowing question, but it's all right. What do we have? 2E. No, it's not too bad. All right, this is the next differentiation question, guys. Cross-sectional area. Somebody was mentioning cross-sectional area before, but I think it was. Give me 1 second, just sorting out the question. Dave B, just find a question and just flick it to me, man. 2017 2C. 2C, is that a merit question there, Stellar? Kian will probably be around. I'll try and get there before 8:30, man. But for the complex proof question, something like no, Callum. I think you've. This is my final part for the. That's all that what I've done in the red. That's basically fine. Edran, which question is yours, Edran? Is that an integration one that you asked me? Oh, damn. Sorry, man. I just couldn't. Parametric. Can you just give me the question number, Edran? I'll. Sorry, man. I'm just doing like looking at multiple screens at the moment, but send screenshot. Okay, is that? Let me just have a look. Let me have a look. 2018. Okay. Edran, find the second derivative. Okay, yeah, okay. Give me a second. That looks like parametric equation. Okay. I'll put that up there, Edran. I think I've just got to do another integration question and I'll come back to it, all right? Whew, got a few questions up here as well. Okay. Yep, no worries, Edran. I can do that on the side real quickly because that's not a tough one. So, okay, so this question here, what we've been asked to find is, what have we been asked to find? Which gives the maximum copper sheet of width 24 is folded, and we want to know, find the angle which gives the maximum cross-sectional area. Good Lord. Okay. So basically this is what's happening, right? So we could have something like this, where that's theta and that's theta, or you could have something like this. So how are we going to work this out? What do these guys do? Sine theta, cos theta. That's interesting. See, I know the answer schedule actually has another way of doing this, but I'm just thinking, why do they have 64 sine theta? No wonder you guys have trouble with these types of questions. 8. That's going to be 8. Fine, I'm going to do it slightly different, this question, guys. It might not actually work exactly, but I'm going to use area of a trapezium. Okay, area of a trapezium is half times base times height. I wonder if this is going to work or not. I mean, I don't know. It might not actually work, but we won't know until we try and figure it out. So here's the thing. Because these lines here, they're parallel lines, right? So if that's theta, this angle here is going to be theta. So I'm talking about parallel lines between this and this. Now the 24 is it's something to mess you around. Destiny, trust me, you're not. You're going to be fine with this question, because just be patient and have a look at how I do this question. So what you have is you've got a right angle triangle here, right here. Okay. Now if we take sine theta, then we've got adjacent and opposite. So I'm going to take this triangle out separately. 8 is the hypotenuse, right? So in other words, I can actually say sine theta is equal to opposite over hypotenuse, or h sine theta is equal to opposite. Then cos theta, no, I did this wrong, sorry. Yeah, I realized it. Doing the same thing again. Cos theta is adjacent over hypotenuse. So then hypotenuse is 8. So I'm going to get h cos theta is equal to adjacent. So I'm going to replace my h with 8. Which means my adjacent is going to be 8 cos theta, which is this. And this is also going to be 8 cos theta. And this part here is going to be 8. Now, as for my height, is going to be 8 sine theta. Sweet. So let's actually do this. So I've got half. Man, you know I'm slow today, eh? I actually went half times base times height, which is area of a triangle, not a trapezium. So for trapezium, you're going to get the two sides added together, multiplied by the height. So I've got my bottom side, which is 8. That's this one here. So that's the A part. Plus B, which is going to be 8 plus 8 cos theta plus 8 cos theta. So this is the other side that I'm looking at, which is all of this. That entire part. Would that be 16 cos theta? Yes. Yep, definitely will be. But I'm just showing you guys how it actually comes out. And then finally, it's multiplied by the height, which is 8 sine theta, which is this part here. So we can rewrite this as half multiplied by 16. Now I actually understand. So this part they don't actually explain in your schedule at all. And then that gets multiplied by 8 sine theta. So 8 sine theta times a half is 4 sine theta multiplied by 16 plus 16 cos theta. So area is equal to 64 sine theta plus 64 sine theta cos theta. So that's what the equation for the area is. Now from here, what these guys in the answer schedule did was they actually made it, because they saw sine theta, cos theta, they actually use double angles. Using double angles definitely makes it easier, but let's assume that some of you guys might not see it as a double angle. Do you guys want me to show you the long method, or are you happy for me to use a double angle? What I mean by double angle is this part here. See this sine theta, cos theta, I can get rid of it. The reason I can get rid of it is because of this thing here. Destiny, doing it up to here is nothing so far, but if you differentiate this, you get a merit. Both. One of the other method is actually, it takes a bit longer, but I'll show you guys anyway, because you're going to end up with a product rule, but I'll show you guys. So when we differentiate area, we're going to get 64 cos theta plus 64 cos theta plus 64 sine theta, and differentiation of cos theta is negative sine theta. That is not right. That looks way too easy. No, that looks right. Are you guys okay with what I did there? Night Shadow, as I was mentioning to a few people before, man, I will have a kind of like a debrief of level 2 after I finish with the calculus tutorials over the next 2 days. Sure. So this this part here is direct differentiation. This one I had to do product rule. So this was F and this was G. So if you look at it, this is F dash G, this is F, this is G dash. Yeah, that's why it's using that double angle will make it a little bit easier. Destiny, I did it quick because it was just sine theta and cosine theta. That's why I kind of was like, I can just do that real quickly straight away. If it was like something a bit more complicated, then I would separate the things and do it properly, but in this case it was just like nice. Thank you for that. Yeah, double angle is easier, but you're still gonna get with the same issues again. So that's why I'll look, if you were using the double angle, I'll do it on this side here. So what happens is this becomes area is equal to 64 sine theta, and what happens is this becomes plus 32 sine 2 theta. Because look at this, this is like double of that, so 64 divided by 2 becomes 32. So that's, you just write it another way, that's all. So then A dash is equal to 64 cos theta plus 64 differentiation of sine 2 theta. Let me do it a long way for you guys. So you're going to get 32 cos 2 theta times 2. So A dash is equal to 64 cos theta plus 64 cos 2 theta. Now this 2 right here is the differentiation of 2 theta. Tim Tam, let's see how we go, alright? Because I've got a couple of more questions I want to work on. Unless somebody has got, what are the exams tomorrow? anybody got health or Samoan tomorrow for level 3 or scholarship physics, then we might take a break. But otherwise, I'm just thinking of other people doing like different exams. But anyway, look, what happens is you still have to use one of these formulas, whether you like it or not, because when you get to a dash, you write this as 64 cos theta plus 64 cos squared theta minus 64 sine squared theta. And look what happens, guys. We take 64 as a common factor in that second two terms, and we are going to get cos squared theta minus sine squared theta. And if you look at this cos squared theta minus sine squared theta is right here, equal to cos 2a. Which means, doesn't matter which method you take, you are still going to end up with the same answer as you did here. Okay, let me just have a look. So guys, once we get this part, we put it equal to 0, right? So because that's when maximum happens, maximum or minimum. So 0 is equal to 64 cos theta plus 64 cos 2 theta. You gotta be kidding me. There's no other way to do this apart from this one method. Okay, you guys are gonna hate me for this, but just be patient with this one, because when you get to this part, I wonder if you can actually do this through graphics calculator. Can you do this through graphics calculator? I want to check it out. Just give me 1 second. I just want to put this in graphics calculator and see if this works out. Because if it works out, then we at least know what our final answer is going to be. We got 64 cos theta plus 64 cos of 2 theta. Mm-mm-mm. 1.04. Yeah, it's not as crazy as what I get for my level 1 and level 2 streams. No, that should be 1.047. 60 degrees. Okay, let's have a look. 1.047. Times 180 over pi times 1.047. Ah, damn it. 60 degrees? Yeah, roughly 60 degrees. Okay, so it does, you can actually get the answer from the calculator, but that's not going to be good enough for you guys, but at least we know that that's what the closest answer is. So what we have to do is we've got to try and solve this, right? Now the problem is you guys actually don't know how to solve this if you haven't actually done some sort of trigonometry identities. No worries, Vusen, it'll keep going. Just catch up with it tomorrow. I'll just keep going through these questions. So, and I think you guys would have done this for the level 2, if you guys did level 2 algebra last year, you would have done this whole substitution for quadratic equations. So remember how they have those really weird looking questions like where you have to go p is equal to I'm trying to think of a question off the top of my head. So sometimes they have this question in x plus 1, square root of x plus 1 minus 6 equals to 0. And then you got to go p is equal to square root of x plus 1, and then rewrite this as p squared plus p minus 6 equals to 0. Do you guys remember how to do that? That's exactly what's going to happen here. But the only thing is, we've got cos theta and we've got cos 2 theta. What would be ideal is if we can get rid of this cos 2 theta and replace it with cos squared theta. So if we go back to our little formula from the double angle sheet, we could actually replace cos 2 theta with 2 cos squared a minus 1. So, and that's what I'm going to do. So I'm going to rewrite this as 0 is equal to 64 cos theta plus 64 2 cos squared theta minus 1. Are you guys happy with that? Because then what I can do is I can take out 64 as a common factor and rewrite this as cos theta plus 2 cos squared theta minus 1 equals to minus 1. Now get rid of the 64, which means I'm going to get 0 is equal to 2 cos squared theta plus cos theta minus 1. And right now, you guys should be able to see that quadratic equation popping up, because this is equal to 2p squared plus p minus 1. And we might just put something like let p is equal to cos theta. So we're going to factorize this and we're going to get what p is equal to. So again, don't waste time. Just go into normal polynomial degree 2, 2, 1, negative 1. There's our two answers. We've got 0.5 and negative 1. Yeah, I know, Destiny, that is the most annoying thing. But the cool thing is, like, when you see these types of questions, you know, these are little tricks and things that you learn as you start doing lots of these practice questions. Like, the more questions you, like, the more excellence questions you guys actually attempt, the more you start seeing tricks. But here we go. So what we've got here is cos theta equals 0.5 or cos theta equals negative 1. So I'm going to go into my normal mode. I'm going to change my angle to degrees. So shift cos of 0.5 is equal to 60. So theta is equal to 60 degrees. I told you guys that's what we got in the answers before. We're not really going to worry too much about, we are going to work out what negative 1 is. Have a look what happens when we do. We actually get 180 degrees. But remember, this diagram that we had, it looked like this, where theta was there. So theta can't actually be 180 degrees, because if it's 180 degrees, then it's going to be a flat line. So our final answer is going to be 60 degrees. And what is the question asked for? I think the question just asked for find angle theta to give maximum area. Royal Hemlock, you could give angle in this in radians as well. It's absolutely fine. But see, for me, the reason I like working in degrees, particularly with these types of questions, is because if you did it in radians, you would have got this as your answer. Okay, let me show you what I mean by, like, look, if you actually go shift setup to radians, and if I do cos of negative 1, I actually get 3.14, right? But the problem with 3.14 is that I can't visualize it. I can't visualize what 3.14 degrees is going to look like. But if you tell me the angle is 180 degrees, then I know 180 degrees can't be right, because that means this theta is going to be, it's almost like folded this way, if that makes sense. So that's how I know that degrees kind of works for real-time questions like this. Where are we at? So Kian, going back to your kind of idea, is that, look, just when you get like double angles and substituting things like that, just keep having a look at this. Abigail, not necessarily, because you can still get an E7 with minor errors. Houston, you're still here. All right. So this was question, sorry, which one was this? This was 2015, was it? No, this was 2013, 2E. Meh, I'm still awake, so let's just keep going. What's the next question I had was an integration question. 2015. I know, Dave, you keep asking me this question, man. Let me just find it. Give me a second. Dave. Oh, yeah, I see it. Is it the triathlete question, Dave? I actually did an activity on this for calculus 2 years ago. Dave, just to make things a bit easy, do you want to just, if it's from a, could you just screenshot me the answer as well, just so that I don't actually go on a wild goose chase? Okay, while Dave's doing that, I got a request for a real 2015 1E integration. Give me a second. 2015 integration. 570. One E. No. If this is 1E. Okay, so whoever asked me question integration 2015 1E, I have done this question before. It is in my playlist called Calculus Daily Excellence Edition. If you have a look at it, it will be there. So I'm going to skip 2015 1E. Whoever asked me that, I'm sorry, but I've already done that one. 2017 2C. (2017 2C). That's a merit question. Two C. Yep, Edrin, your parametric is coming up next, my friend, after this quick question. Actually, no, wait, I'll just do your question, Edrin, real quickly. Give me a second, because it is a short one. So Edrin asked me this one here, because it shouldn't take me too long. 4 sine t and y is equal to 5 cos t. So find the second derivative. Now, Edrin, to do this question, you need to get the equation from, where is it? Parametric function. Here we go. You need this equation from the formula sheet, and then you should be good to go. And guys, I know sometimes like people go like, this is a real easy question, but people do mess it up real quickly. So you're supposed to figure out what the second derivative for this is. So how we do this is, the first step is we got to figure out what dx dt is. So dx dt is going to be 4 cos t. dy dt is going to be -5 sine t. Okay, give me a second, Chloe. I'll put it down. I'll just do these two, and then I'm going to go to that integration question. Okay, so then dy dx is equal to dy dt multiplied by dt dx. So dy dt is -5 sine t multiplied by dt dx is 1/4 cos t. So we can rewrite this as -1.25 sine t over cos t. Now remember, sine over cos is equal to tan, so we can rewrite this as -1.25 tan of t. So now, if you look at the second part of this, which is the second derivative is going to be differentiation of dy dx with respect to dt multiplied by dt dx. So we've got to differentiate this for this part here, which means that's going to be -1.25 sec squared t multiplied by dt dx is 1/4 cos t. And I think that's pretty much it. You've done second derivative right there. Is that all right, Edrin? Minus internal radius is square root of 2. Chloe, did you want me to actually do that whole question for you, the circle question that you sent me? Nah, Destiny, that's definitely a merit question, man. All right, which one are we going, guys? We're doing integration or? Okay, let's do an integration one, the 2C, another merit question that came up. Okay, triathlon question is coming, I think, next. Manav, I'm not sleepy yet, so I'm kind of just going through it. Might just take like a 2-minute break and then I'll come back and just keep doing some more. Okay, so our next one that we're doing Which one is this? 2017 2C. No worries, Leah. I'll check the question later that you sent me just to see you're working. All right. Edran, what happened, Edran? Did you get a different answer for that previous question? Yep, that's exactly what we got, Edran. -5. Just to show you how they got that. Sorry guys, I'm just going to go back to this quickly. Basically, -1.25 is -5/4, and then sec squared theta could be written as cos squared t, and then it's multiplied by 4 cos t. So we're going to get -5/16 cos cubed t. But you can actually leave your answer there like that, Edran, so it's fine. Sorry, let's go back to that integration question. Okay, so with the integration question here, you will have to do it in 2 parts. Do you? No. Well, you could actually do it this way. Let me just show you guys. Give me a second. 14.2 as the quadratic. Because you want to find the shaded region, right? So you could actually do the yellow triangle minus the area, the blue parabola part there. So what we've got is the yellow triangle minus the blue parabola part equals the gray, I'm just going to shade it black right now, the black part. So in this case, we've got between 14 and 2, and the equation of a straight line is given, which is -x plus 14 minus, and in this one, we've got it between 5 and 2, which is -x squared plus 3x plus 10. Is that all right, guys, what I've done there? Yeah, it's all right. Waiting, Kian. Don't worry. Yeah, you can do that too for the triangle. That's absolutely fine. You could do, what, 6 times 12. So it should be the same. Oh, it's a 14. Sorry. Yep. Thank you. Sweet. So we're going to integrate this. When we integrate this, we're going to get -x squared over 2 plus 14x, and that's between 14 and 2, minus -x cubed over 3 plus 3x squared over 2 plus 10x, and that's between 5 and 2. I think the question actually said -x plus 14. I just did a copy error. Yeah, it was -x plus 14. Now, for this part here, let me just show you guys. You can actually do this part in the calculator, because I'm not gonna, like, how do I say it? I mean, you can actually expand it and do the calculation the long way that you want, but really you just go into option, go into calculus, put integral. I'm gonna put my first one, which is -x plus 14, and I want it between 2 and 14. So I don't need to do any integration. I just write the original function, right? Which equals to 72. And I've got integral of negative x squared plus 3x plus 10. And that's between 2 and 5. Which equals 22.5. And subtracting that, I get 49.5. So for the grades wise, stupid thing. That's going to be a merit. Correct integration of both expressions gets you an achieved. So you get both of those right, you get an achieved. Yes, AJ Hooksy, I did read it. I'll probably have a chat with the level 2 guys a couple of days after I finish the calculus tutorials for level 3s. Yeah, Kian, you can actually do the third step in the calculator because you don't want to be wasting time putting in all those numbers. And Sonica, I don't know. It really depends on the exam papers. Like sometimes it's 6, sometimes it's 7, sometimes it's 8. So can't really tell, unfortunately. All right. Now Chloe didn't respond to us, so we're gonna. Tim Tam, you still here for your question? Oh no, Dave. Dave, where is Dave? Dave's question. Okay. Plus 32.8. Oh, yep. Okay. Goose chase coming up here. Actually, it's not too bad, so. Okay, Tim Tam. All right, fine. I'll go through Dave's question and then I'll go through Tim Tam's question as well. Triathlon is running up a riverbank. Needs to. Whoa, that just blew up. Yeah, no worries. You're welcome, Blossom. Let's see what's happening here. Triathlon is running up a riverbank and needs to swim across the 32-meter wide river in order to finish. The athlete can run up to 6. What doesn't make sense is it doesn't actually tell us how much distance it is. See, this is why I ask him to send me the answer, because sometimes these guys ask really silly questions and make us think. Why is it 32? Yeah, no, I got it, Dave. I'm just having a look at it. Just trying to figure out how to explain it to you guys. 32 meter wide, swim at 1.8. Because the original problem that I did, I actually had like a distance that you could run at. But in this one, it's actually not giving us. Is there any previous questions, Dave, before this one? Oh, no, I get what's happening. No. Sweet. Don't worry. I got it. So, I think sometimes the best way to actually do this is x minus x over 6. Kind of draw this, but give me a second. I just want to double check that I want to. X over 6, 32, 1.8. Then why does that go distance? Minus x squared. Yeah. Okay, let's see. If we get the swimmer, this is the start line, right? Let's say he actually goes x distance along the bank. Then crosses over. That part there is what, 32? No, that's not going to work. I'm actually stumped in this one at this moment. This is what happens towards. What do you understand, Dave? Dave, because like the way I did it was like I usually have this distance here, but I don't actually have this distance. I mean, I know that the time, how much short of the perpendicular from the finish line should he enter the water? Nah, Kian, sometimes these questions, they just don't give us any kind of. I need one more bit of information. At least that's how I've seen this question before. And the answer that they've given is this. I'll show you guys the answer. Like something they've done is like x over 6 plus 32 over 1.8 minus. How do they get to this? Is what I don't understand. The perpendicular line is 32 meters. Yeah. I mean, I get where they get that d is equal to we don't. If we don't, then the only thing that I can think about is jeez. Okay, no, that doesn't make sense. X. Let's try this again. So if I don't work with the distance, then the athlete can run at 6 meters. So that's going to be x over 6. That's going to be 32 over 1.8. D is equal to square root of x squared plus 32 squared over 1.8, because that's his water speed. His water speed is 1.8. It's just minimization of x to maximize time taken. So the time taken is this. Okay. Yep, Dave, yep, I got it. I got what you're trying to say. Okay, so sorry guys, I know this is what I mean by stumped when I get this tired, but basically it's that there's things that can happen. Like if he was to do this method here, that's is going to be that's that black part right there, right? Then if he was to actually go across from the start to finish, then that's going to be the red part here. So what we want to know is what is, how short is it? So we literally have to just differentiate this. That's all it is, to figure out how much time he actually saves. So we're going to get 1 over 6 plus 32.8. I don't think that really matters because it's just a number. Whoa, what happened to my thing? And I now have to differentiate this function here, which is, what is it? I'm going to rewrite this as x squared plus 32 squared to the power of half. So minus half times x squared plus 32 squared to the power of negative half multiplied by negative 2x, and the whole thing is divided by 1.8. So we're going to get 1 over 6 plus the 2 and 2 cancels out. The negative and negative cancels out. We're going to get x squared plus 32 squared to the power of negative half over 1.8. Yeah, that's what it is. It was a distance over time, because x is the distance divided by 6, which is the speed. So we're trying to figure out how much time you can actually save. So I think what I made a mistake was, like, you can kind of say that this was the start. So at this point, we're going to put 0 is equal to 1 over 6 plus x over 1.8 x squared plus 32 squared to the power of positive half. So rearranging this, we are going to get negative 1 over 6 equals x 1.8 x squared plus 32 squared to the power of half. We're going to end up with a ugly looking equation, but we'll figure it out. So we've got 1.8 over 6 x squared plus 32 squared to the power of half is equal to x. Now negative 1.8 over 6, I just want to get rid of it. Is this going to be a nice number is the question. There's negative 0.3. Rearranging it, I get x squared plus 32 squared to the power of half equals x over negative 0.3. Square and square. And what I end up with is x squared plus 32 squared equals x squared over 0.09, and there we go. So x squared minus x squared over 0.09 equals 32 squared. And if I solve this, that's not right. Why is it not right? Something's not right here. I've made a mistake somewhere. Oh, minus. Damn it. It's minus 32 squared. So minus 10.11 x squared equals negative 32 squared. So x squared is equal to 32 squared divided by negative 10.11. I hope that's right, Dave, because just that, x squared is equal to 101.25 something, and then x is equal to, or 27, yeah, that's fine. What do I do? So 32 squared divided by 10.1111, and then square root of that, 10.06. I think which is what you got there before, Dave. So Dave, just to check how we actually form that equation, it's like this. See, if he starts from here and he goes along there, that's going to be x over 6, right? And then if he comes back down, that's going to be 32 over 1.8. So if he takes the yellow path, this is his yellow path right now. But then the green part is this part here. So we want to try and figure out how to keep that time the minimum. And so that's why we want to actually try and figure out how short of a distance that is. You could almost say I live in an airport, Stellula. It is pretty close. If you have time, 2015 differentiation. Kian, which question was that? So sorry, Dave, that took a little bit longer than expected. Oh, did we do this question before? I get a very weird feeling that we did this question before, Kian. Can I just quickly check? No, we've not done it yet. Although I think I've done it before somewhere. Okay, 2015, Kian, is that you subtract because you want to try and figure out how much time you want to save, and ideally you don't want to yeah. So when you go along that yellow line and then you're trying to like minimize the time when you're going to go through the green line. Yeah, sorry, Tim Tam, your question is up next, man. Kian, I'm going to come back to yours because that is a really good question to have. right, this is Tim Tam's question. I do apologize, Dave, because as I said, as it gets a bit late in the night, I start getting a bit slower. Anyway, guys, by the way, I do apologize. I think this might be my last question. I didn't realize the time's at 11:20 right now. Okay, so we are doing this last one here. Yes, I did, Suyash. I'll talk about it later, man. I want to try and get through this question, Tim Tam. So what we have here is area under the curve. So this is the ugly looking curve between x equals to k. So we're going to write this down. Between x equals to k and x equals to 0. And k is bigger than 0 is 8. So that's what we have so far. That's all right, Edwin. Tim Tam, are we okay with that so far? That's an integration question, by the way. Now, when you see a square root symbol, guys, my suggestion is this. Do substitution, all right? Because otherwise it just becomes a lot more complicated. So I'm going to do u substitution. I'm going to put u is equal to kx cubed plus 1. And here's the thing. When you do u substitution, you want to actually do du dx as well. And I did forget one thing. I forgot dx there. So du dx is equal to 3kx squared. All right. Now, once you do this, no worries, Stellala. I think, yeah, I've got to talk to my level 3s because some of you guys have been working with for nearly 3 years. I got a tiny favor to ask from you guys sometime in July next year, but I'll talk to you guys later about it. It's not a priority right now, but let's get through this. One thing that I'll say, Tim Tam, is this. Have a look at this part here. See, in the numerator, you've got kx squared dx. And if you look at your u substitution, you've got a kx squared there, and then you've got a dx there. All right. So what you want to do is you can rewrite this as du over 3 equals kx squared dx like that. Because that means we can actually get rid of kx squared dx completely from that equation. So we could rewrite this as, well, let's forget about the k0, 8 and all of that. Let's just do integration of kx squared dx over square root of kx cubed plus 1. So then what's going to happen is we simply write this as, because kx squared dx is equal to du over 3, so that's the du over 3. Remember this? We've gotten rid of the kx squared dx. And we've got multiplied by 1 over square root of u. Thanks, Suyash. I appreciate it, man. Yes, Dave, you could do reverse chain rule as well. That's absolutely fine if you're comfortable with it. Cool. So what we have is a very nice, simple du function that we need to integrate. So I'm going to kind of go over here and I'm going to write this as 1 over 3 u to the power of half du. Now bring u to the numerator before doing anything. Actually, I'm going to take 1/3 out just because it's a friggin' pain. And that's going to become u to the power of negative half du. So this will become 1/3 u to the power of, now negative half plus 1 is positive half, divided by the new power, which is a positive half. And that's it. So we can rewrite this as 2 over 3 u to the power of half. All right, we don't need to worry about the plus c or anything like that. We just leave it as it is. So remember, now this, we're going to substitute u back in, which is going to be kx cubed plus 1 to the power of half. And this is between k and 0, which equals to 8. Let me know if I've made a mistake there somewhere, guys. Dave, is that what you got as well for chain rule? Interesting question there. Oh, I see what you're trying to assume. Are you you actually find out what u is and then put u back into for kx cubed plus 1. Is that what you're talking about, Dave? Yeah, I mean, you could use that, but sometimes, yeah, I just don't want people to get confused. I know what you're talking about. You could actually change the bounds from k to 0 to something else. This would be an excellent question, I think, Hyper. Just because there's so much work to be done, because we're not finished yet. I just wanted to show this part first. So the next part we've got to do is 2 over 3 k to the power of 3 plus 1 to the power of half minus 2/3 k to the power of 0 cubed plus 1 to the power of half is equal to 8. Now 2/3 is a common factor, so I can take it out. So I take out 2/3 and I rewrite this as k to the power of 4 plus 1 to the power of half minus, what have I got here? 0, 1, 1 to the power of half, and that's equal to 8. If u sub in dx, I think integrating this should be a merit because it's a quadratic, not a quadratic, it's a substitution. Would it be? Yeah, I'm sure it should be a merit for integration, but don't quote me on that. Anyway, let's just keep going with this. We're going to get k4 plus 1 to the power of half minus 1 equals 8 times 3 over 2. So we got k to the power of 4 plus 1 to the power of half is equal to 8 times 3, 24, 12 plus 1. (13), and then k to the power of 4 plus 1 equals 13 squared. K to the power of 4 equals 169 minus 1. I hope this is correct. This looks very weird. That's what I'm getting as ks. I hope that's what you got there as your answer, Tim Tam. We're still waiting for Tim Tam. Yeah, same. Yeah, as I said, Dave, there's like multiple ways of doing this, so you can kind of mess around with it. You can do substitution, and yeah, you can actually do that both ways. Cool, guys. Very late into the night, but I'm gonna say that's basically it from me for this little help desk. So if you guys got any final questions, just some real quick ones, like just general questions, I'm happy to help. But please, yeah, no, you're welcome. No worries, guys. Just get some rest and get back to it tomorrow, and I'll see you guys tomorrow. Yep. I'll do one tomorrow, but I won't be streaming it this late, obviously, because tomorrow the next night is the exam night. But we'll probably finish at 10:30 tomorrow night so that you guys can actually get some sleep. We'll finish at 10:30, so what time we start basically depends on what time my kid goes to sleep, because he went to sleep a bit late today. But I will try and get him to bed by like 8. But tough ask. Stellila, going back to what I was gonna ask you guys. I mean, this is just I mean, if you wanna support in some way. So basically, not this year, but for next year. So there's like these goals that I have, and one of my goals is to actually kind of like work through this. So get through this. So at some point I might just ask you guys to help me with this, but for now, just keep doing this. Cool. So guys, I will catch you tomorrow night. And that's basically it from me this session. So Stellar, that's what I was talking about, man. If you do, that would be great. But that doesn't open up till next year, sometime in July. Sweet. Anyway, guys, I am calling it a night. Thank you again for joining this late with no notice, but I'll see you tomorrow and rest up. We got one more. By the way, just strange question to ask you guys before I leave. If I do an afternoon stream, would people be keen tomorrow? Because I got a couple of hours to kill. Okay, well, we'll try and work something out. Just keep this kind of, what do you call it? Whatever you guys do to know when I pop up. But yeah, I'll check my schedule and see if I can actually run either like an early morning one or afternoon one. And what I might just do is I might just start working on the questions that people have actually put up, because I'm gonna have to do it from my school. So I usually just start streaming straight away, Nathan. But otherwise, I might just put it up on Instagram that I'm streaming through stories. Okay, cool. I'm out, guys. Have a good night.